the end of the semester, last day of class, so that's a big milestone for everyone. What it also means is this is a little bit more of a kind of a grab bag lecture. There's really two topics I wanted to cover that I didn't get a chance to cover yet. One about data science positions. That was actually going to be the subject of the last lecture, but I ended up taking the full 2 lectures to do the walkthrough, which is fine. But I wanted to mention a little bit about sort of data science positions, especially because I am aware that the reason for a lot of people taking this course is to think about applying for positions as data scientists. So I want to give you sort of my thoughts. I've worked both in academics and in industry, so I want to give you my thoughts on kind of what sorts of positions there are available and what kind of things you want to actually focus on as a data scientist or as someone applying for data science jobs. And then also, though, I want to put a little bit of time into talking about the ethics of data science. And I mean that pretty broadly. We're not going to go into any detail here, but I really want to highlight 2 things. I want to highlight, first of all, how a lot of times these data science systems that we talk about here, they do raise ethical issues that we don't fully address at all in this course, right? So we really don't address sort of the philosophical issues of data science here. We are addressing the technical issues. But there is actually a very nice body of work that kind of brings these 2 things together to a certain extent. So looks at theoretical ways of looking at bias and fairness in classifiers and what kinds of guarantees or statements you can make there. And I'll mention that only very, very briefly here, kind of to highlight these things, but also then step back a bit and talk about some of the bigger questions that a lot of these problems actually raise kind of in practice, right? When we talk about practical usage of data science, what kind of comes up. And then finally, we'll have a few final thoughts. And also, if there's time, I would like to have some Q&A, but we'll see if there's actually time for that. Before I start, so I had a poll last time on the final, and whether you're going to have it in the morning at 8:30 or in the evening at morning 8:30 a.m. or the evening at 8:30 p.m. And I think actually we're going to likely do both. We're going to do it in 2 sessions, and you only have to come to one of the 2. And you can actually let us know ahead of time which one you're going to come to so we can assign sort of the assignments properly. The issue is actually that even with 90-second videos, if everyone submits a 90-second video, we will actually run out of time in 3 hours. That 3 hours is not enough time to watch all these videos. So we're going to watch half of them in the morning and half of them approximately in the evening. It also means you might not see your own video, but it'll still give you a good chance to see a lot of other people's videos, see what sort of what people are up to. And I think therefore, you only sit for about 2 hours instead of 3.5 almost, which could be can get pretty mind-numbing after a while, even with exciting projects like these. So we're probably going to split into 2. I'll follow up on that with announcements sent over email, sent via Piazza, but I'll check the box to send everyone emails. The default, of course, is that we have it at the final time. I'm not sure which room we've been assigned, but some big room. I think this room actually, and we'll kind of go from there. So I'll follow up on that. We also have this room that same evening, and you'll submit to one of those two times. Okay, so let's talk first about data science positions. So I want to start off with the polls. Maybe a bad idea because everyone will just head off after you've answered the poll. But I know the people here are often taking this course because you're interested in data science positions. So I'm actually curious now. This is maybe actually even different than it would have been at the start of the semester, since I think a lot of people here applied possibly during, and I talked to people that were applying during the semester. But I'm curious here who in the course, who is sitting at least in this room, has either applied for a data science position, has done a data science internship, has done a data science position full-time, or is interested just generally in applying for data science positions. So let me get those. This is obviously no right answer on this poll, but I'm actually very curious about the results here. So a quick look. So ignore the last. I guess you ignore the last one because put there. This one could just maybe have to fill out this one, or you can't submit the poll, or if maybe people didn't submit the poll because you had to select one of them, so you just didn't submit. Okay, so about half maybe, or at least half the people here today have applied for data science position at one point. A lot fewer have done internships, and even fewer have worked full time and then maybe coming back to school after that, which is sort of expected. This one, I guess everyone's maybe interested, but as I said before, you have to answer one, I guess, as was said. So maybe that shouldn't take too much into that. Okay, so obviously as I said, this is a big reason to take this course, is if you're interested in data science positions. And in some sense, this course was sort of, coming from industry, I actually did, or spending some time in industry, I wanted to see, what a course centered around kind of the topics that I saw being used in industry would look like. But before I talk about sort of data science positions, I want to emphasize a few things. And that is, there's still no good definition of what a data scientist actually is. And it's a trendy term right now. So of course, every position advertises itself as being data science these days. And you see, the data science positions that are advertised that are really, when it comes down to it, kind of, they could have been called 20 years ago business analysts. They're just now been renamed to a data scientist, right? So this is not exhaustive, but I do see a lot of positions that are really for sort of traditional business analytics or traditional business analysis of data that are now called data scientists, right? And you're mainly working like in Excel there. You're not really doing the techniques we talk about so much, but you're still doing valuable analysis. But now it's called data scientist, data scientist. I've also seen a lot of just sort of statistician jobs, right? That we used to be called statisticians. You work for a large company, you have to analyze their data. That used to be called a statistician, and now it's called data scientist. In fact, even the statistics department here, right, rebranded to the statistics and data science department. So clearly there is some desire to actually capitalize on that term for maybe the cynical representation, but also the reality is maybe that's actually a better term for what a lot of these people feel like we're actually doing, right? We're not just sort of looking at the actual, the job of a lot of statisticians is not to investigate statistics per se. It is really to analyze concrete data and make decisions, and I think that name fits data scientists very well these days. There's also a set of data scientists that sort of I would call them like data product designers, so that your goal really is you're sort of like a product manager or designer of some tool at the company or some product at the company, but really your goal is to sort of think about developing data-driven tools for how you can develop new tools for clients and things like this. There's the machine learning engineer, right, that is really just doing machine learning research or machine learning implementation maybe, but that also can fall sometimes under the rubric of data scientists. And then finally, there's sort of the tools developer, but I guess as I say, that this is not exhaustive either. So the tools developer, develops actual software that other data scientists can use to actually do their analysis, right? Now, I actually don't want to spend too much time dwelling on this because I don't think these distinctions are that important. I think they are sort of, in some sense, kind of accidental to a large degree, right? They're all can be, people do want to sort of capitalize on this name, and depending on what the description of the job is, it might obviously be one of these more than the other ones. But these are all, I think, valid to call data scientists in some sense or another. What I do want to highlight, though, is that there are some important distinctions that you should consider if you are interested in applying for data science jobs. And the way and I think these distinctions actually will make a very big difference in sort of the types of sort of the actual work you do on a day-to-day basis. And so when you're applying to a position and trying to figure out, is this sort of something I would enjoy or not, it's good to sort of have these questions in mind in terms of what you may or may not want to do in your job. So the first one is that there's this big distinction, I think, between companies who are in some sense kind of their core product is the result of data science. And companies that are operating along just fine that would like to add some data science type analysis to their current pipeline. Right? So in some sense, there are all these businesses sort of springing up that kind of their business really is the analysis of data, right? They analyze data from search engines or search queries and try to provide a service to a search engine provider, right? They analyze data from tax data or stuff like this, right, and try to provide insight into either how you can do your taxes better or how someone can how the population as a whole is paying their taxes, right? So there are all these companies that kind of are built fundamentally around data analysis. But there's also a whole other set of companies that are just sort of doing fine, right? They're a company that sells some product. They're doing just fine as a company. But they also want to be intelligent about their company and actually use data to make better and more informed decisions. Now, and so they're going to hire data scientists to analyze their bucket of data, and they're going to use that analysis hopefully to improve their product. This distinction actually is quite important, though, because in the first case, the data science really is kind of in some sense a first-class citizen, and I'm not actually saying anything bad about the second one either. The data in the first case really is kind of the core thing that they're selling, or the analysis is the core thing they're selling. Whereas in the second case, they're sort of more, it's the company's sort of fine on their own, right? The company is sort of chugging along. They would do fine without data analysis, but they hopefully just do a little bit better with this analysis. And so I think that really is a big difference there, and one you should be aware of when you apply for positions. The second one is that there's a big difference in people that will be developing data science tools, of course, versus actually doing data science. So you know, if you are largely interested in writing software and building platforms that actually can help you know, the rest of the team or do better data science, that's one type of position. But the other type of position is one that actually sort of, you know, analyzes actual data using those tools. And figuring out where you line that spectrum is actually a very important one. And the final one kind of is the sort of more classical statistical approaches versus more geared towards machine learning. Machine learning, it kind of is sort of does seem to be kind of the more popular. I shouldn't say popular. It is there are more such positions that are being advertised because machine learning happens to be hot right now. But there are plenty of kind of more classical statistical analysis type positions that do extremely valuable analysis for these companies, and so they're sort of very important to kind of proceed along those lines as well. So a question I get a lot is sort of how do you go about actually applying for data science positions given all this, right? Given the fact that you know there's actually different types of positions out there, if you were applying for a data science position, you're saying in your resume, how do you actually go about doing that? And this is one of my own advice. I think kind of your mileage may vary here. I don't pretend to have sort of a solution to this, especially given a few caveats on the next slide about requirements that they list as requirements. But I would sort of say three things that sort of that I've seen as being very indicative of people that, you know, proceed to next stages in data science interviews. The first one is to actually figure out what the position you're applying for really is about, which may seem obvious, but it's actually oftentimes people apply to positions that they're just woefully unqualified for, and you're going to have no. I mean, even if you are qualified actually, but just you haven't updated your resume to make it clear that what the position you're actually applying for really is, you're not going to have any luck there. If your position highlights, you know, skills in Excel and this kind of things, and the position is for, you know, machine learning algorithm design, you're not going to have much luck. And vice versa, by the way, too. If the position really is for business analytics, and you did nothing but highlight sort of how you're really good at Jupyter and PyTorch, you maybe get some traction just because those things are really hot right now, but you probably actually won't. And you probably won't be happy in that job anyway, and so I wouldn't recommend that. So figure out what the position actually is, which one of these categories, both in this page and this page the position really is, and apply with that intent. You know, make your statement kind of for that particular position. The second thing is that you should definitely highlight relevant coursework. You know, mention that you took this course, but that's not really going to count for very much because everyone takes some courses in something, right? So that actually the more important thing probably is to highlight tangible experience. That could be, you know, the project you work on, because that can be, you know, you can put that up on GitHub. You can actually highlight it to potential employers and say this is a piece of work that we actually did, and that has much more. I think that carries much more weight than just a bunch of coursework and a bunch of, you know, homework assignments you've done. People have a very hard time. It's very hard to know just how much that actually, how valuable those things actually are for a lot of employers. And then do mention that this is sort of the least important, but just yes, you should do it. You should mention the tools you know. People do sort of spot checks for do they know these technologies or not. I wish we didn't. I wish that this wasn't an issue actually, but often companies will do that. So look what the position's applying, you know, is asking for. Obviously, don't make anything up, but every skill that they're asking for, every sort of piece of software that they're asking for that you know about, definitely list that on your resume. It's just easy. It's an easy checkbox for, you know, the HR department to first go through so that you get past the first screen. The bigger issue that I think though with data science jobs, and this is sort of, I mean, this is probably stuff that's applicable to any position you're applying for, but I think especially the second one is often lost on, is often something I don't see, but something that does differentiate a lot of people in applying for data science positions. Okay, so the other thing though that I do see and that people often mention to me when they talk about sort of their applications for data science positions is that they get a little bit discouraged when they're looking at different positions because they all seem to require 5 years of experience or having a PhD and all these things for positions that don't really seem like they really need it. I mean, you're doing sort of basic data analysis. Do you really need 5 years of experience before you can do that effectively? And what I would actually say is, for the most part, that these are not actual requirements of these positions. There are very few data science positions that really do require a PhD, for instance. There are some, but most of them don't. What's really happening here is that, unless it's for a really senior role, but even then, frankly, I guess the PhD or the experience, unless it's a really, really senior role, it's not going to necessarily differentiate between really star employees and people that aren't a good fit for the positions. What they're really trying to do here is they're trying to filter out a high variance group. So the year I was in industry, we were actively hiring for data science positions in my department, and we would get about 5 applicants a day from various from everywhere with resumes. Some of them were completely obviously not qualified for the position, right? They just didn't have any of the skills or tools they were looking for. And so the reason why people list those requirements is to try, maybe unsuccessfully, but to try to pose some sort of filter to minimize the variance of the pool of applicants, right? It's very hard to look through many applicants with different degrees and really determine who are the best ones. Having said that, and especially if it's a small startup, right, and you want to be data scientist for a small startup, they just don't have the time or the bandwidth to look through 5 applicants a day to figure out who the best people really are. And so there's a good chance, because of these reasons, you won't hear back from a lot of companies, right? Your resume will just fall through the cracks, and you won't really hear back. So my thought on this is that if you are so these things are not actual requirements. If you are able to somehow make contact with people at the company, not just by cold emailing them, because they get plenty of those too, but if you actually have a genuine contact that you could actually use to get introduction to the company, there are many times when there's a position that lists 5 years of experience that would be perfectly open to having a fresh graduate do that. It's just that they don't want to say that because then they get not just 5 applicants a day, but 20 a day. So it really is a matter of, in some sense, it's a little bit about playing a game. There is unfortunately kind of a network effect here. It's somewhat unavoidable, but I would strongly recommend that if you really want a position at a given company, don't be deterred by sort of the official lists of requirements here. Okay, so any questions or actually even just comments on this? Because I'm actually curious about people's experiences and what they've found in similar things. Yes? Okay. Yep. Yeah. Right. So okay, good. I'm glad that it backs up my experience as well. So yes. So the point is that they are much more interested in finding smart, motivated people than they are in finding someone with 5 years of experience. They just have to put that so they don't get 50 people or 20 people a day applying. Okay. So actually, the next question I have is for people that have here applied to data science positions and even actually interviewed. The next thing I want to talk about is the data science interview, very briefly. Who here has interviewed for a data science position? By show of hands. Okay, what over there? What shirt? In the red shirt. What questions were you asked in the? Okay, here's data set. Throw to the fence. Analyze it. I see. Okay, interesting. Anyone else? Who else is? Yeah.
Get an interview for data analyst.
Okay.
And they asked me this question is, what is the biggest mistake data analyst can do?
Okay. Actually, I haven't heard of that one. Yeah. Did they explain their what scenario? Okay. Yep. Okay, interesting. Yeah.
Ask about the matrix that will be applicable to which situation.
Okay.
If precision recall would be more relevant.
Uh-huh. Anyone else? Yeah.
A large data set, and one example there was a missing feature.
Mm-hmm.
And so we had to use bias, k-nearest neighbors to approximate the missing feature.
Okay. So this is sort of like a hands-on. I guess I realize I should be repeating these responses because it's going to be a really boring video otherwise. So the idea was that they gave you a data set, and they asked you essentially to figure out how to fill in missing entries in the data. I guess some of the others were they asked you what the biggest mistake a data analyst can make. I haven't heard that one before. I actually have, and this is interesting because I haven't talked with many people in the industry as a whole. I mean, I have been, but I haven't talked with sort of about the data science interview process from other companies and the ones I'm not involved with in a little while. So that's actually really interesting to see. So I typically see the following types of questions in data science interviews. And maybe this has changed now. It sounds like it actually is changing. It sounds like this one is actually much more common now. And I guess general kind of higher level questions seem to be becoming more popular these days. So actually, maybe this doesn't even fit into one of the categories here. So I would see first of all, there are usually a collection of software engineering interview questions. So maybe this is not the case anymore. Certainly, when I was talking with sort of people, and I think probably some there still are, they still ask you the basic questions of if I have some list of terms that I know is sorted, but it's not a complete list. How do I actually construct like an ordering of all the symbols in this language that I don't know, right? There's kind of standard things you do in sort of programming assignments, or how do you generate all anagrams for a word and stuff like this, right? So I see those a lot actually still in people talking with people. They just didn't mention it, but did you have those in your interviews as well? Okay, so you still had those. You still did have the kind of traditional, okay, how do you sort of list, that kind of stuff. I see this one now less. The second one, that used to be that in data science interviews, they would ask you to write SQL queries. That does seem to happen a lot less right now. But they actually would. Did anyone get asked to write a SQL query? Okay, so you were still asked to write that. Okay, I do see that one happening less than it used to be. I guess people don't really care about SQL as much anymore. They assume you can look it up and sort of know how to use it. I still do see a lot of stuff about machine learning, and they are typically more general questions, like the ideas of training and testing errors, validation, stuff like that. But there are sometimes questions directly on, how does k-means work? How does logistic regression work, right? They'll sort of ask you that kind of point blank and expect you to kind of describe it in some terms or not. So was anyone asked a machine learning question, like kind of an algorithmic machine learning question? Interesting. So actually not that many more than the other ones, or maybe people are just only a slew of hands are going up now. This one I also see more rarely now. Was anyone asked about hypothesis testing in an interview? You were. Okay. This is good. We're touching on a lot of things. I think actually this one is good to touch on, but I see it much less than I used to see it. People, for whatever reason, even though the fact that statistics is kind of moving towards data science or rebranding as data science, a lot of times there's less talk about statistical hypothesis testing and stuff like that in a lot of these interviews, and sort of it's good that it still is there sometimes, I guess. And then finally, this one's becoming even more and more prominent, and I think this was actually emphasized by some people. If not actually take home, then at least they will ask you to either sit there in some capacity, or they'll give it to you to take home. They'll ask you basically to do a little data analysis project. That is very, very common. I definitely see why that's becoming so popular. It does give you a sense of sort of, what this person can kind of really do. It's also really contrived because, as was pointed out before, sometimes the data is completely fake, or if it's not fake, they make you sign all this stuff to do it, and so it's kind of an odd process. And so it's not always clear. They typically actually have an answer in mind, unfortunately, when they do this, even though the whole point of data science is there shouldn't be answers in mind. You just sort of be figuring out what the data tells you. So it's a little bit, it's not a perfect scheme, but I think there is some value to it too, right? It's hard to ask someone questions like, do you know k-means or not, and hope that this will somehow tell you if they're a good data scientist or not, and asking them to actually do some piece of data analysis can be a pretty good strategy. So I do see this more and more this last one here. And I would imagine that if you go, especially if you go to later stages of interviews, there's a very good chance you're going to have to sit and kind of do a mini project or a mini report and kind of present the work that you did to your interview team. People, I take it, have seen this, right? A lot of people did this one here. Okay, so this is sort of that really is kind of the extent of most, yeah. Another.
I also think one thing that's catching on is some companies have had interviews with the product managers.
Yeah.
And they'll ask the questions, like more conceptual questions of how would you define a problem, how do you collect that data, how do you go through this whole pipeline,
Yeah.
deliverable.
Yeah, that's a good point. So I think this is also mentioned there is that and maybe it really should be a sixth category here is that there are also questions about how data science ties in with larger product development questions, right? So it's not just sort of how do you analyze data, it's how would you come up with a data science, to solve this product problem, or how would you interact with someone developing this product? How would you use data science kind of at a high level to solve this problem? And so those questions are often not with other data scientists or technical people, but they're with higher level people that are also, it's a good point, yeah. Okay, so that's actually most of what I wanted to say about data science positions. The last thing I'll say is when it comes to things like, when it comes to actually academics, is that data science as such is not really, modulo, the statistics department are naming themselves, but there isn't a lot of research, academic research in data science. So if you want to do data science research, whatever that means, I would actually probably be a bad person to approach on a research side because my research is not in data science, it's in machine learning. And so the work I do is not really not all at least, data science driven. There are applications we have that are sort of data science-like, but it's very much, we're developing the algorithms, which is distinct from data science. The reality is that most sort of top data science work that I see academically is actually in other fields, right? It's using techniques from data science to actually do science in some other area, right? In computer science, I'm fond of saying this, there isn't really much science in computer science for the most part, right? We're sort of an engineering field. We build things, we build systems, we analyze those systems, and we prove things about them. We don't form hypotheses and test them and validate these things, right? The control in most computer science is that you just don't run the program and then nothing happens. So what I would say, and of course I'm being a little bit tongue-in-cheek there, but I think if there's true to a certain extent. So what I mean by that is that most top examples that I see of data science really are in other fields, things like civil engineering or engineering and public policy. These kinds of fields where they have all this data, all of a sudden they need to analyze, and they're able to bring in these techniques from data science to do things that are of huge relevance to their field, actually applied relevance to their field, that is sort of outside the bounds, that is outside the bounds of what's been done before, because people didn't know how to do that data analysis before. So that's what I see most commonly in kind of the top, what I would call data science applications, at least in academics. Now, I should say this. What I mean by this is the academic work, I would say now in sort of core data science in some sense. This is sort of fundamental data science research, if there was such a thing, was really either kind of, either fundamental research in machine learning or statistics, and this is, I would include myself in this first category here, with sometimes data science-like applications. So, I do work in applications in smart energy systems. I do work in applications in some other areas, and having some data science-like applications along with new algorithmic development is a very common trend you will see academically. And the second thing that you may see is there's also some nice work on kind of trying to automate aspects of data science. So that is definitely an active research area, trying to see if we can build some sort of tools, some systems that can actually automate the process of some of the things data scientists do at least. And that's very much sort of active development, and things like the automatic statistician are good applications of that. But as I said before, I think the most compelling work that I see in data science in some sense is really actually in other fields that are not directly related to computer science, but which are using these techniques very powerfully. Okay, so that's sort of the first random topic of this lecture here. Any questions at this point, or thoughts or comments or anything? Yeah. Why did I come back to academics? I was only ever going to go away from academics for a year. That was always my plan in the beginning. I wanted to, frankly, see how these techniques that I was, working on academically could be applied in the real world. I'm still certainly involved in industry work, but it was always kind of a year that I was going to go and then come back here. I know a lot of academics say that and then don't mean it, but I really meant it. I do really like the fundamental research when it comes down to it. I really do like the aspects that we have and the aspects of teaching and stuff, right? I mean, I think that's actually something that's very hard to get in a lot of company environments, and so being able to do research and teach is something that is hard to find elsewhere. Okay, so let's move to actually a completely different topic now, and one that I think is actually a good one to talk about at the very end of a course in data science. And probably should have had more lectures on this, frankly, but maybe for the next offering, these things are becoming more and more prominent. Maybe the next offering we actually will have a little bit more to say on this. But the next topic I want to talk about is that of ethics in data science. Okay, so I want to start off with a exchange or a post I saw on Twitter about a month ago or so. Someone, I don't want to say who they are because I hope I didn't leave it in there anyway. I don't say. I mean, you can figure it out. Obviously, you can obviously search for it if you really care. But that's not the point. They were talking about hiring data science positions, and they were talking about how it's easy to build in an ethics question into a data science interview. And so sprinkle this in with your tech questions, for example. And the question is, you're working on a model for customer access to a financial service, and race is a significant feature in your model, but you can't use race. What do you do? And according to them, the wrong answer is to say that you'll use the zip code because that correlates with race. That's the wrong answer. And the right answer here is to remove race as a factor and just accept lower accuracy of your model. And this actually sort of struck a chord with me because it's completely wrong in some sense. This is actually not the right answer at all. This would not work. This is what people have tried to do, which was causing a lot of bias in algorithms. I would say this is also clearly the wrong answer too, right? It's also sort of a silly question. I mean, I know it's Twitter, so you're trying to just sort of show you're posing the question at a high level. But I would hope that if someone asks you, how do you avoid bias in a classifier, you don't say, well, I'm going to trick the classifier into really being biased, and that's how I'm going to solve it. You shouldn't answer that when you're being asked that. So I'm not sure. I guess some people might answer that, and they're just thinking that you want that. But I think it really goes more to say what they think you want rather than that. Oh, I think I lost the picture here. Oops. Huh. Okay. Well, I have a link coming up next. But I want to go through why this is actually the wrong answer. Why this is not the right thing to do. And the reality is, you can't. So if you have a data science system, you're building some classifier, and you want it to be fair in some sense, the natural reaction people have is, oh, well, I'll just not let it use any information that I think would be unfair. Like I won't let it use race or gender or these other things we feel like shouldn't affect the outcome, and that'll solve the problem. Right? That'll make it an unbiased and fair classifier. And that's not true. And it's really important to realize that is not true. How you fix it for real is a very hard question to answer. There are some techniques for it that I'll just mention here. I won't really go into them in detail. But this is not the right thing to do. So this is not, I mean, maybe it's the right answer to the interview question. It's not the right answer to actually what you do to avoid bias in algorithms. So I'm missing the picture here. I don't know how that fell out. But a really influential study in, I think, 2016 was done by this group, ProPublica. And they looked at bias in recidivism prediction in the US legal system. So this is basically when a judge is setting your bail, they'll try to predict how likely you are to either commit another crime if you're released, or when they're granting parole decisions too, they'll predict how likely you are to reoffend, right, and then go back, end up back in prison. And as you might imagine, this study showed that these decisions that essentially are now run largely, or not largely, but oftentimes are assisted greatly through software, are heavily biased in their decisions. They're heavily biased against blacks in general. They typically have a much higher prediction that someone who's black will reoffend than someone who is white. And they sort of showed this in a very kind of damning way, this ProPublica article, and it was I think a really powerful indictment of these systems. And essentially, there's 2 points here that I sort of want to make. So the first one is that on some level, machine learning and other inference algorithms, they're making predictions based upon data, right? So if your data is built out of heavily biased systems, the results of those predictions you make from the biased data, we're also going to have that bias. Somehow the fact that these systems are automated does not remove any bias from them. If anything, just the opposite. It has nothing to sort of check its nature of bias and stand in the way of being biased, and it's sort of free to use the results of huge bias that's developed over generations. And so there's a good chance, so if your training data suffers from bias, there's a good chance the algorithm will suffer from bias in the same way. The same has been shown based upon race for different financial loan algorithms, right? So algorithms from banks that will determine if you should give you a loan or not also tend to be heavily biased based upon race. And then the point I want to make, though, is that, and I would really recommend reading that article. It's a really great article, and it really highlights these points in really stark detail. The point I want to make, though, is that the quick fix everyone thinks they can propose is just to remove race as a feature, right? Oh, just remove race. Of course you shouldn't use race to predict whether someone is going to reoffend as a criminal or not. Just remove it from your features, right? The point, though, is that the system that ProPublica analyzed, that system did not have race as a feature, right? So it wasn't doing the obvious thing where it just said, okay, based upon this race, I think you're this much more likely to commit a crime. It wasn't doing something like that. What it was doing was actually but at the same time, it was still clearly making decisions that were heavily influenced by the race of the person being analyzed in some way, right? And the fundamental problem here is that the data is still biased, right, in some way. And I'll actually go beyond just the data being biased itself. But the data has these biases in it. And if you remove something like race, it is still the case that race is heavily correlated with a lot of other features in your data, right? We know that for a fact. That's sort of part of the story of bias here, right? Is that race is correlated with other features in your data. And so if you remove race as a feature, all the machine learning algorithms will do is they'll try to find correlation between the other elements of your input data and the output they're trying to predict. You're not going to be removing the bias anyway. You're just sort of shifting that bias to other effects, right? So that's actually a big important point there, is that it's much, for example, this is not a good thing to do either, but it would be much better to train a model that included race as a feature and then just zero out that weight explicitly in your final model. Don't do that. That doesn't solve the problem by any means. It's not a good solution, but it's a much better solution than removing the feature entirely. Then that way you at least first try to account for it, try to figure out what the bias is in the data, and then explicitly remove that. And so that's not quite the right way to do it, but the point is correct in that what you need to do for these things, you actually need to include all these things as features and then explicitly remove bias from the actual trained system. And so that's actually the way that you should do things, not by trying to take out certain features and hope that, therefore a system is going to be somehow unbiased, right? And in fact, I do want to just mention that there actually is some very nice technical analysis here. And this deals with this fact of, okay, so that all sounds fine, but what's the right way to remove bias then, right? How do I actually go about removing bias from my data set if I've trained a model on potentially biased data, right? And that's actually a really hard question. There isn't any obvious answers, and there's some, but there are some very sophisticated kind of nice techniques that can actually do this. One possibility that I actually want to highlight here, and they also did some really sort of impressive analysis. Well, I'll get to that later in a second. One possibility here, which was introduced by Moritz Hart and his collaborators, is something called equalized odds. Actually, I also teach another course here, and my co-lecturer taught a lecture that just discussed this thing on Monday in some detail. I won't, of course, cover it in any detail, but I just want to mention that these things are out there. So I'm going to define it formally here. Don't worry about this formal definition, but I'll try to convey some of the intuition here. The idea is something called equalized odds, and the idea here is that we have some, these are all random variables now, so I'm actually going to have a little bit of math in this final lecture. I won't write it down on the thing, but I have a little bit of math here. This is things that you should be able to understand given that we've already covered probability now. If I have some predicted outcome y hat, so this is the thing that the algorithm predicts. You actually don't have to worry about how it's doing it. It can be based on whatever you want it to be based upon, but it's just making some prediction y hat given some data. You have some what's called a protected attribute. So this is some feature like race that you do not want your classifier to treat unfairly in any way. It should be, and then you have the true outcome, which is, for example, did this person reoffend or not? Okay. So a very nice definition of fairness in some sense is that the probability, your probability that you predict that someone's going to, say, reoffend, should be conditionally independent of this predicted attribute, given the truth about whether they offended or not. So this is sort of a weird statement to make, because if you have the truth, you just always predict that, right? But you don't have the truth at test time. You have to make your prediction somehow other way. But this is actually a really interesting statement, because what this says is, what we can do is we can look at the subset of people that really didn't reoffend, say. So we look at all these people that were sort of categorized by this system, classified by, say, systems that grades the probability of reoffending or not. We look at the ones that really didn't reoffend. These are the ones where this y variable is actually 0. So we know they didn't actually reoffend, right? They did not commit another crime. They didn't go to jail. And we can look at not sort of for any individual person, because it's hard to judge probabilities there, but for the entire set, the entire population of all the people that didn't reoffend, you can look at what is the probability given to by these systems that they will reoffend for a class of people, say that for say black people that are being looked at here versus white people, right? And what's been shown. And this seems like a clear thing, because in this case, you actually have ground truth, right? In all these cases, people did not reoffend. It seems like a pretty strong indication that, other people that don't reoffend, you really should be able to predict in both groups equally well. And what was found is that even looking at, for example, in the ProPublica article, is that even looking at only those populations where the true outcome was one or the other, right? So only looking at the people that really did not reoffend, these systems would predict a much higher rate of reoffense for the black population than for the white population. And so they really are truly fundamentally biased in some sense, right? Because these are people where the right answer is known. They did not actually reoffend. Or if in the case of, say, housing loans, if these are people that maybe did or did not pay back their actual loan. And what we find is that systems in general, the current system like this recidivism prediction, also systems like credit scores, are heavily biased and essentially penalize people for their race. And there's no real way around this, because these are the populations. You can look at the actual ground truth. You can look at the actual ground truth at the population level, and you can see these systems are actually penalizing people for their race, even though race is not a feature for these systems. Okay, and that's actually a really important point, is that removing race from these things does not make them fair. What you need to do, actually, is you need to include race and explicitly account for these effects. And also, actually, in this paper, they provide a way to take a potentially biased classifier and adjust its predictions in a certain way, given certain knowledge of the population, just population statistics, in order to make it fair. So it's I think it's a really compelling both definition of fairness and a compelling kind of way to solve these things. And I think it's had a lot of sort of influence on the community since then. Any questions on this? I know the bigger thing I would say is sort of to go check out this paper if you're curious of that, because it's a really sort of good idea. And I think even as a practical thing, and they have a really nice example when it comes to credit scores. It's a really sort of both practical and kind of deep and insightful piece of work. Yeah.
Instead of removing the feature,
Yeah.
let us suppose in a hypothetical scenario, I remove the data points where a person is black. and I train the data entirely on white people.
Okay.
Interpreted, I mean, how do you look at it as a data scientist if I tend to remove it because I feel that if I could train it on white people, supposing that their decisions made on them are not biased, and use the same model to predict whatever the future offenses are for the black people in the future.
Yeah.
So how is it going to be?
Right. So that definitely is not, that definitely doesn't work either. Again, it's the same problem, right? If your data inherently is biased, and your past decisions have been biased, then training a model only on black people is going to perpetuate those same biases because that bias is going to be present in that population.
I'm saying, let us train a model only on the white people. We are supposing that white people are not biased and usually.
Right. So, yeah. So if you train a model, modulo any other considerations, if you train a model only on the sort of the people or a certain class that you feel has been not unfairly biased against in the past. The problem is you're still then, when you go to a different class, there are still differences in these two populations in terms of the rest of their features, and those are going to be indicative, and there's no guarantee that these things will not somehow lead to higher or lower, but oftentimes practically here higher misclassifications of the population you didn't train on. It's never a good idea to train up on to evaluate a system on a population you never trained it on, right? You're making out of sample predictions now. You really can't do it, and the reality is you can't. Because there are such strong correlations between this and other effects that are caused that are sort of related to race, it's going to be very hard to train a system without explicitly accounting for bias that is unbiased. I would actually say impossible because the systems are the data as it is inherently, it just is biased inherently. It has been biased from a system that's been sort of has been factually biased for a very long time, right? And so you can't just sort of do a quick fix and say, okay, I think this population isn't biased here, so we're just going to train on that. You really have to account for the bias in the data and try to explicitly correct for that. Is the correct way to do things. Any other questions? Okay, so the last thing I'll say, which is a slightly different topic actually, which is a little bit higher level. I'm not going to get into it in some detail. That there also is some technical work on this topic. But the last thing I want to mention is a slightly different take on this, which is not really not really fairness, but with rather privacy. So we all have sort of heard the recent news which unfolded while you were taking this course about the Cambridge Analytica company that I guess. In 2000, I can't remember what year it was now. It was I think 2012 or so. They scraped, they set up some Facebook app that, if your friends took some quiz, they would actually send your data to this company. This company built profiles on all these different users, and then they used it during the 2016 campaign to do something. I mean, I think actually some of the connections with the campaign are sensationalized a little bit because politics is very sensational here. But the reality is this company was still doing things that was using data that people clearly had not ever authorized them to use or to make use of, and they were attempting to influence these people based upon that data. I don't want to. And actually, some people I know were negatively affected personally, not because maybe you were during the actual election, but several people, when this came out, Facebook shut down a lot of their APIs. So people started their projects on APIs based upon Facebook, had to actually change gears in the project in several instances because they shut down certain bits of information. You can no longer, for example, scrape a lot of Facebook or Instagram feeds, I know, because of this. Not to make light, there are, of course, much more serious issues here going on. And I don't want to touch too much on this. I think actually the science of privacy, at least at this level, is less well understood. I mean, obviously, I think privacy and things like health records, stuff like that, are a little bit more understood. There's work in fields called differential privacy that kind of determines, can you do analysis on a data set that says things about aggregate populations without revealing information about a specific person, and that seems reasonable. But these are things where actually where the individual features are really what's important here. And the question is, more fundamentally and kind of philosophically, should we be running these kind of analyses based upon people's private data, right? Is it really worth doing to analyze, what kind of ads we can show someone to target a particular, they'll target a particular candidate based upon their past political statements or based upon information they sort of shared without ever thinking it would be delivered, used to influence advertising given to them, for instance. And so I kind of want to just almost leave it at that with just a few questions at the end here. And the reality is that this data is becoming more and more available, right? So Facebook is getting more and more data about our lives, about sort of everything that we do. We are becoming more and more sort of online in a lot of ways, right? A lot of more of our information is actually developed online and kind of spread online. And in a lot of cases, the companies really, their business plan is to collect this data and analyze it to a certain extent, right? But even ignoring the issues of bias and fairness, I think it's becomes an important question to ask is that what kind of inferences analyses do we actually want to do with this data, right? Do we want to predict how likely someone is to commit suicide, for example, from their social media posts? I mean, that's actually seen as maybe a good thing, but at the same time, if you start doing that, then what else are you sort of, and you then take action based upon that, what are the implications of the system you've built here, right? So there's a lot of sort of good intentions that when they are actually used in practice seem like they are not being used for good purposes, and seem like we really shouldn't really need to think more about what kinds of information we both what kinds of analysis we actually do on people on this data, and what actions we take based upon those analyses. So the former U.S. chief data scientist, a guy named DJ Patil, he recently has been kind of promoting this notion of a code of ethics for data scientists. And while nothing has really been stated yet, I don't think we're close to having a code of ethics yet. It is the case that I think the field has reached a point where we have to take these considerations very seriously. I think we used to be kind of a little bit enamored with what we could do in terms of sort of the analysis that was possible. That a lot of the notions of sort of what kind of things really make sense to do and really are good types of products to exist in the world was not thought about, right? It was really much more about technological feasibility rather than sort of ethical and moral rightness. So that's all I want to say. I think I'm not an ethicist, or I'm not really a philosopher in any way, as it's probably showing right now. But these are thoughts that are becoming more and more prevalent right now, right? These are realities that we can't really ignore. And while this course really just deals with the technical capacity to do analysis of data, when you think about unleashing all this sort of power on a massive amount of data and a massive sort of group of people, it becomes really important to have some notion of kind of the ethical underlyings of whatever you're actually doing with this data. So that's all I'll say there. But I want to just, I think these things are going to be becoming more and more important as we do have more and more data. And I think that these topics are going to be more and more relevant going forward. Okay. So just some final thoughts, and then we'll have time for some question and answer if people still have questions after this whole course. So one question I get a lot is about the future of data science, right? What's the future of data science going to entail? It's very difficult to predict technological trends. I should say that. It's very hard to make predictions, especially about the future, is a famous quote. And for example, I work in AI and machine learning right now. I honestly don't know what's going to happen with the recent surge in artificial intelligence. I don't know where it's going. I don't know if it's going to fizzle out, this whole deep learning thing, or if it's going to just become the new normal. It's really hard for me to say. I have some opinions, but when I actually have to make predictions, it's quite difficult. But I am pretty confident that data science sort of is in some sense here to stay, mainly because it's been here for a long time. And all that really is happening now is that we're getting access to more and more data and more sources of information that make this a more and more powerful thing. It might get a different name after a while. I mean, data science is a relatively new term. Maybe we'll rebrand again. be something else. This will be some other course in 10 years. But I think that these techniques and these sort of topics are really not ones that are subject to the whims of sort of trends in technology and stuff like that. They're really fundamental techniques that are going to remain for a while. So I think really the immediate future of data science, and in addition to all the things I talked about before about the increased concern about ethics and privacy and fairness, more concern about both the privacy in terms of what should we be doing, what data should we be actually using for these things, as well as when we use this data, can we guarantee in some way things are fair. In addition to those topics, I do think that what we're going to keep seeing, and if we haven't already seen it, is what we're going to keep seeing is we're going to keep seeing kind of the data science. The data sciencification of a lot of more fields. So I think we are sort of at the turning point right now in a lot of areas. Some places have already been thoroughly inundated already with data analysis, and so those are already kind of turned that leaf. But many fields are still those that have only begun to really look at the full source of data they have. So if I am to predict the future of data science, what I would say is that what's going to happen is that more and more in more and more fields, these techniques are not going to be kind of the outliers or the cutting edge of research. These are going to be standard methods that everyone in this field knows. So when you talk about energy systems, and actually I'm listing things here that I've worked in personally. So I've personally worked in things like energy systems, building management, wind power, material science, chemical engineering, aerospace, robotics, fluid dynamics, etc. These are techniques, these are fields that are really pretty far removed from data in a lot of cases, right? I mean, they're, robotics really isn't thought of as a data-driven field. But in all sort of cases, or industrial manufacturing, right? In all sort of cases, these are things where the prevalence of data and the techniques we've talked about here in this course seem to really be shaping these fields going forward, and it seems like they're going to keep shaping the fields going forward. So my sort of takeaway from this is that if you're looking for what data science is going to be in the next 5 years, the techniques will evolve. Yes, techniques will actually keep sort of marching along. We'll have new techniques. I'm sure the libraries will definitely change. So what tools you're using will definitely change. But the reality is, whatever area you work in, and possibly even more so, the farther removed you are from traditional data science in your or the traditional kind of computer science and statistics in your main field, the more you'll see an influx of these techniques really being at the core of whatever field you happen to be in. Obviously not displacing any of the foundational kind of science and mathematics that underlie a lot of fields, but really kind of supplementing them and giving a different perspective on a lot of these things. So I think a lot of fields in engineering, I think a lot of fields beyond engineering, in the humanities and social sciences, these kind of things, are going to be more and more influenced by data going forward. And these techniques are going to become more and more a part of not just computer science or statistics, but really the rest of the entire swath of research fields. Covering this entire campus, for example. And what I would say is, if you don't see this happening in your field of choice, then you should probably think about being the one to pioneer it, because it will happen at some point, and there's no better person than someone that comes from a different field that has started to also learn kind of the techniques of data science. Just a recap. Well, we're nearing the end now. Just to recap what you learned in this course, right? So it's pretty impressive if you look back what we've covered in this course, right? We've covered data processing, so we started off with web scraping, right? Way back in I guess I talked about web scraping in my tutorial or my walkthrough as well, so that one's maybe fresh in your mind. We talked about a lot of other stuff too, right? Relational data, databases, matrices, graphs, networks, free text. Geospatial, if you read the tutorial on that. A lot of classical learning methods like linear regression, feature transformations, overfitting, cross-validation, testing, that kind of stuff. A lot of sort of more advanced methods like boosting decision trees, deep learning, mixtures of Gaussians, dimensionality reduction, stuff like this. And then finally, a couple other things like big data, MapReduce, and then finally, I think my sort of personal favorite thing to talk about, which is debugging data science, because I think it's one that's typically not covered well enough in other courses. And the last thing I'll say is that this is meant as sort of a broad introduction. Of course, these things are topics that each have their own course here in a lot of cases. So I would sort of end by saying that CMU is really an amazing place for this kind of work. The nice thing about CMU is that, as I said, there's not going to be one course that covers all these things, though we did here. There's really going to be 30 courses that each cover a small aspect and, of course, go well beyond anything we remotely covered here. So to name a few, I mean, of course, things like machine learning are going to be courses where you're able to, so this would be 10.601, 10.701, are going to be courses where you can kind of build the core foundations of machine learning algorithms better. The stats versions, like 402, Advanced Data Analytics, are also kind of the more statistical side of things, but also very sort of foundationally algorithmic. There's one in HCI, I actually don't know when that's going to be offered again, but Interactive Data Science is another one offered in HCI. There's a course on machine learning with big data sets. There's a course on multimedia databases and data mining. Artificial intelligence courses, I actually teach these pair here of 15780 is the graduate version and 381 is the undergraduate version. I think actually it's 381, 681 now, so it's undergraduate and master's version. And then there are things like machine learning for text mining or deep learning. I think this is a not at all exhaustive list. There are probably 20 more of these that are ongoing right now and being proposed right now. The other big things happening at CMU right now is that we're introducing in CS an AI major. So people in CS, actually, I don't think, maybe not this class, but you'll see the courses coming about. There's going to be a lot more courses kind of in AI that kind of relate to these topics. And so this is going to be something that's very, very, very prominent going forward. And so I think that there's going to be a lot of these things that are becoming more and more prominent and more visible at the university level. This is probably the best place in the world, I really think so, to start thinking about topics in AI, to think about topics in machine learning kind of things. We have probably the most, the broadest and kind of most diverse set of faculty working on these things. And so it's a wonderful place. And I would really recommend that everyone check out these other resources that we have and figure out whatever kind of data science you want to do, whether it be more applied or more sort of theoretical or not data science at all, really. I think you'll find something here that can really sort of expand your horizons and your techniques that really, really vastly. So that's actually all I want to say. I do have some time for question and answers if there is time, but otherwise it was really a wonderful semester. I really loved having everyone here. We have the final projects but the videos for those will be in a week or so. I'll follow up about the exact timing of those things. And I do mean to actually stay for questions and answers if people have any, so don't go if you do have questions, though I think people are going to run off. But it's great having everyone here, and thank you very much.